Okay. Right. Can you hear my voice, everyone? Hello.
Yes, Bu.
Okay. Sorry for that. Okay. So we got the F, we got the S, and also we got the M for the mixing. So the next step is how to find the extract and the raffinate. So what should you do?
Never rule, Bu. Eh,
Uh,
no, I mean,
the
sorry.
thing
The raffinate and the extract, drawing the line from to the
Yeah.
back, Bu.
Okay. The good thing is here we have the tie line already. Yeah. But if you have tie line around this area, then you have to do the interpolation like I explained to you before. So you got the extract and you got the raffinate. Maybe raffinate one and extract. And with referral rule, you can find the extract and the raffinate. You just do calculation and also read them with the vertical one and also the horizontal one. Okay. So this gonna be your first the number, yeah, your extract and composition in the first stage. Okay, and how about the second stage? Now the second stage, again, because of this is across a batch, yeah, a batch for two stages. So in the stage one, you have a solvent and also the feed, and here you got the extract number one and also the raffinate number one. The second one, your raffinate should be contacted again with the solvent. So the point of the raffinate here should be contacted with the solvent over there. Yeah. So then what you need to do is to draw again the line, connect between uh, the S, yeah, the solvent there with the raffinate there. Okay, and that with the similar because if the solvent ratio alpha always 2/1, and then with that particular approach you can draw again, for example, your M, I don't know, so maybe again divided into 3, something like that, for example in this area, let's say, yeah, and then you draw again there, and then you get the E2 and the R1. Okay, so of course in this case there would be a number of errors, yeah, the way you read it, the way you interpret the data. So as long as it is a parallax errors or just with your eyes, for example, it should be, if I read it here, for example, it should be 12 and I write 13 or 14, that's fine, yeah, except if it is looks like this and then you say 20, of course it is wrong. Okay, so as long as the variation is between the parallax between the eyes with
Sorry, Ibu, I don't think we can hear you. You're cracking up.
oh, okay, I'm still cracking up. Okay, looks like I have to move from my office here. So then I think I'll move. Yeah, just wait a little bit. Okay, how about this one? Can you hear me now?
You can.
Yes, Bu.
Is it better? Right. Okay. Okay. Just continue again. So yeah. Here you can see you can read the extract and the raffinate. I think of course please use it, and then I will open the MS Team to um, so you can submit, yeah, your your work, and then I can have a quick check on your graph. Is it okay or not? Okay. So any deviation regarding the reading, if it is parallax reading, and then for example these points between 12.5 or 13 or 12, as long as it's not much, it's fine. Yeah? But if you, for example, you have these points here with, let me give you.
Bu, sorry Bu, you're not sharing the PPT. Yeah.
Okay, what I'm saying then? Oh, okay. How about the desktop? How about this one? This?
Yes Bu, we can see it now Bu.
Okay, right. Yeah, as long as you have the different variation, yeah, with and yeah, 12.5 or 13, that's fine. Okay, so based on that one. Okay, so after this, I'm gonna open the MS Team for the assignments for quiz 1 for today. Please solve it and then give it, submit it, and then I will have a quick chat. Okay, I think yeah, but first, please, we have to understand the basic, yeah, for that one. Okay, now, any questions regarding the quiz before we move on to the countercurrent extraction?
All good from me Bu.
Okay, okay then, yeah. So let's continue the next one. Yeah, this is the extraction part 3. Okay. So, I think I should go back from the second one first. There, yeah. So this is the second one there. So we have a bit of problem if we calculate it in the triangle diagram with the equilibrium graph, equilibrium composition there. If you want to move to the next step, for example, the third stage or the fourth stage or the fifth stage, it's become difficult to draw around this area, right? So what we can do is actually change this into another graph. Yeah. So see, the number can be known, and then so see from Pak Danu here, I said that if we move on to the next step, 3 stages, 4 stages, 5 stages, it's going to be difficult to follow with the right angle diagram. So we need another way how to construct the diagram and how to put which one is the equilibrium, which one is the operating line. So in the next slides, we will start a different approach. Okay, the first one is, of course, just to remember in the beginning. So this is right angle diagram, triangle diagram. Yeah, and then we have the plate point here, and we have this one is the A, this is the percentage of C, this is the percentage of B. Okay, and this is the Y, yeah, or the vertical axis, and this is the horizontal axis. Around this area is about the raffinate, and around this area is this curve tells you about the extract. Okay, and between the raffinate and extract there is a tie line. Okay, tie line can yeah, so, and also the correlation between the raffinate and the tie line in one point is an equilibrium. Okay, so here so the tie line is actually the equilibrium composition in a raffinate and also the extract. Okay, how we read it? How we're gonna read it? Of course, for the raffinate, we're gonna look at here and then read it to that way. So this is the composition of raffinate, and for the extract, we're gonna look at horizontally here, we're gonna read the composition of the extract. Sometimes we're really looking at also the percentage of the C, yeah. And also for the point of raffinate, if we look at the vertically into the horizontal axis, this is the raffinate, yeah, of the percentage of B. And then this one is also the point for the extract for the percentage of B, and then you can get the percentage of A, which is the remaining 100 minus percentage of C minus percentage of B. Okay, so this is how we read it. Okay, so now we're gonna construct a new a diagram, and this diagram we will convert it into an XY diagram, small x and small y. Yeah, this type of diagram is really beneficial for distillation or or absorption and also extraction, because in any point of the in any point of the typical point in the graph, it can tell you a relationship between the x and also the y. So if this is the line for x equal to y, and for example this is yeah, this is the line where y equal to x. So in any point there, it can tell you at a particular point which one is the y and then which one is x. Now in the extraction, we also have the correlation between the extract and also the raffinate R. Okay, and we want to try to change it into the XY diagram by converting the concentration of the extract as a Y, yeah, this one, the concentration of the extract as the Y, and the concentration of the raffinate as the X. Okay, yeah, so in any particular points, yeah, in any particular points, we know the relationship of the percentage of C in raffinate and also in its extract. Okay, so because the tile line is equilibrium constitution in R and E, so we're gonna read that one there, and then the composition of C of the solute in raffinate and extract, we can call it Y and X. So this tells you only the Y and also the X. Sorry, this is this one also this is also the Y, yeah. Yeah, this is also the Y. Oh yeah. This is the composition of extract and also the raffinate. Okay, for the drawing, how to construct them? It looks like this. I think I would like to draw again. Maybe, yeah. So let me explain this graph first, and after that I will do it myself, try to draw the graph so you can maybe use step by step to draw it. Okay, so this is the triangle diagram, okay, and this is the XY diagram. So this is the X and this is the Y. Okay, yeah, so any points, the points XY, that shows you the concentration C in the extract and also C in the raffinate. Okay, so maybe I can make it a little bit bigger here. Okay, suppose we have this triangle diagram, and this is the equilibrium curve, and this is a tie line between the extract and the raffinate. Okay, so here we draw the similar line, the similar graph, and then we just use the similar the similar scale. Okay, for example, this is from 0 to 1, and then they just only, again, this also similar from 0 to 1. Yeah, from 0 to 1. This also similar from 0 to 1. Okay, because we don't go in here. Yeah, we don't go to this area because it is more than the plate point. Then I will just we will just cut off until 0.75. Yeah. Okay, so how to draw the line? Let's say this is the line here. So the y, yeah, the y for the extract, draw the line up to here. So this is the y for the extract. Okay, and then this one is the composition of the raffinate. Yeah, so because this is a square, so put it here for the x, and then read the x, because this is y equal to x. Yeah, so this reading tell you this is the point of the x, and then go that way, and then we got the points here. Okay, maybe I'll let me try to add some examples. For example, maybe I'll draw just a very maybe like that. Yeah. Usually, if we increase the line, sometimes it can be apa ya? It can be it can goes to one certain point. So let's say I'm gonna draw several tie line. Just an example. Okay. Insert rows. Maybe one. Sometimes when we draw the curve, it should be, to make it nicer, it can maybe like that. Okay, yeah. Okay, for example, these are the tie lines. An example, this is a typical tie line. Okay, so how we construct them? So first, let's just see the higher one. Yeah, so the higher one, for example, we draw the, oops, not this one. Okay, so maybe, for example, first we draw the C. Yeah. So the y for the extract, so draw horizontally there. Okay, got it. So this gonna be your the y for that point. yeah, for the plat point. And then for the x, this correlates, so the E over here correlates with the raffinate over here. So again, with your, I think it's better if you use your ruler, of course, with your ruler, and then draw again the horizontally from the raffinate into the line of the red one. Okay, and then okay, so that one there, yeah. So this one is the x, and then so your points is gonna be around this area. So this tell you that point. So in this point, the pink one here represent the line, the red line here, the higher one. So it respected to the y and also the x. Anyone got it? No? Not yet? Okay. Let me another example. Okay. Let's have another example. I think I would delete this one just to maybe just delete this one. Yeah. Okay. So that's the first one. Yeah. No. Not this one. Not this one. Yeah, the line one is the this one, yeah, the x or the raffinate, draw the line to that area. Okay, that. So this is the y and this is the x, and then connect the dot between the y and x. So then your points for the construction, so this is the x and this is the y. So this is gonna be your point. Yeah, very roughly, yeah. And for plate point is actually in here the constant, the extract and the raffinate is in one point. So then the x would be equal to y. So for the plate point, we only need to draw one line from the here into that point there. Okay, so this is gonna be your sorry, this is gonna yeah, so this is gonna be your plate point. So the meaning of plate point is when the y equal to x, or your extract is equal to your raffinate. So in this point, so this is called plate point. Okay. Maybe we can try another one. I will just write it really rough, yeah, just using a drawing. But when you do it, you have to use your ruler, okay? I'm a little bit tired to use go back with the insert line, something like that. So the next one, for example, in so we have this point again, yeah, for the E over here. And how about this one? So here, the third line there, so go that way, we will have the y, and then the raffinate is around here, there, and then connect the dot between the upper one and the lower one. So this is gonna be your next point. Okay, and then maybe two more. This is the x for the raffinate, and this is the for the extract, maybe. So maybe around this area. Yeah, I'm just gonna quick guess, yeah, but you try to do it by yourself. And then the last one around this is the x, so maybe the x around here, and the y just slightly a little bit higher of the x, so maybe around here. Okay, so that tells you that we have 1, 2, 3, 4, 5, 6, and then because this is the line is actually we can connect all the dots there to make a curve of a tie lines or correlation between the extract and also the extract and also the raffinate. So using, okay, so we can make some sort of curve, yeah. So this is the curve for, maybe put it, so this is the curve, yeah, should be like this. Okay, so then this will tells you the correlation of x and y, or y and x, and in each typical points that tell you the correlation between the percentage of solute in the extract and the percentage of solute in the raffinate. Okay, so I think the yeah, it should be looks like this, yeah. The better one should be looks like this. Okay, so this is my drawing. Of course, it's not perfect, but let's have a look on the next drawing here. So if we have, for example, several tile lines, the tile line, yeah, the black one, the red one, the green one, and the blue one. With this graph, you can typically see the correlation between this is the extract, yeah, for the y, and also the raffinate for the x, and then you get the points. And again, in a flat point, you only have one point there. Okay, and then if we draw the curve like that, it would be look like this. Okay, and then this tells you. So here it kind of now it looks like an equilibrium curve, yeah, of the distillation, a vapor liquid equilibrium, or equilibrium in absorption, like in a Henry's law. Yeah, it kind of looks like this, and then this tells you the concentration of extract in the solute in the extract, and the X tells you the concentration of solute in the raffinate. Yeah, so again, so this one here. Okay, I'm just gonna stop here, and then any questions regarding this one? Of course, I will give you quiz as well. Yeah.
I'm so confused what the value of y and x mean, Bu.
Oh yeah, what is the value of y and x? So y is the concentration of C, or solute, in the extract, and X is the concentration of X, or solute, in the raffinate. Remember, our starting point is from this point. Yeah, this is the tie line. This is the area of raffinate. Yeah, the lower one, and this is the extract, the high one. Okay, and when you read to the vertical, this is the percentage of C. Remember, this is 100% C. This is 0% C. Okay, but when we use the diagram, we won't go to 100% C, of course, because it's only up around here. There's nothing in here. Yeah? We can't reach this area, so maybe this is up to 0.5 example. Okay, so rather than reading in this here, we can read the seeds, because sometimes the one that we want to the particular concentration that we really want to see is the solute. Yeah, how much solute is going into the extract. Yeah, how much the solute that can we extract from the feed. That is the particular ones that really need attention in unit operation, particularly in the extraction. Anyone, please? I'll gonna just wait for your question until there's no question, then I can move on. Again, there's also another quiz about this one, but I would like you to just do it in your house, yeah, because it is not ideal. Usually, before pandemic, I would give a lot of quiz, and then I will go just around of you guys, and then checking of your work one by one, so it is much easier. But now, and then you can also discuss, and also using the pencil and ruler, and then much easier compared to yeah, telling you from online. Okay, but then I will put your work as I will mark them for the quiz works.
Bu,
Yeah.
to be honest, if you look at the right angle triangle and the graph on the right, then X should be the value of B, right, Bu? Then why is it the concentration of C in the raffinate, Bu? Actually, like, if just looking at the graph, I understand, but the actual meaning of the axis, I don't understand it, Bu.
Yeah. Why C is now become the percentage of C in the raffinate? Why is not the B? That's your question?
Yeah, Bu. Since the bottom one, like for the x-axis in the right angle triangle, that one is calculating value of B, right, Bu?
Yeah,
But
yeah.
but why is it when you put it inside the y equals to x, the box, then the x-axis becomes the concentration of C, Bu?
Okay, good questions. Yeah, I understand what I'm saying. Okay, because we won't use the percentage of B in this particular graph. Yeah, this graph only tell you the correlation between extract and raffinate. Yeah, these points or these points, typical point, it's only tell you the concentration of extract and concentration of raffinate. C in the extract and C in the raffinate. So this point here tells you the, for example, we have the feed and also the S. This is that one there. In particular mixing, what is the extract and what is the raffinate? This tell you that one. That's why when we draw the points here, let's see maybe the green one, we will read it from the percentage of Y there, isn't it? Maybe I'll change this into the green as well. So here, yeah, when you read it here, for example, there, yeah. So this is the percentage of C in the extract, right? Isn't it? This one. How you read it?
Yes, Bu.
Yeah, okay. And then this is the extract, and this is the raffinate. This is the percentage of C in the raffinate. Is it right? Yeah?
Yes, Bu.
Yeah. This now I just move the raffinate there into this graph, this line. This line tell you Y equal to X. So if I have the percentage of concentration of C in the raffinate is this one, ya, to dicerminkan ke Y equal to X, then I can say if the X would be again here, this one is the percentage of C in the raffinate. while the y here, yeah, you can I think this one is clearer for you, yeah, because this is tells you the percentage of C in the extract. And then the combination, the ordinate or the vertical one for the extract, the horizontal one is for the raffinate. When you combine them together, it became to one dot. How about that?
Okay, Bu. Thank you, Bu.
Any other question regarding this one? Yeah, I know it's confusing. Why Bu Winnie changed from the percentage to B to X? Yeah, I know. Because it is, I think you can look this as you have 1 point in the distillation, and then that correlates to the composition of vapor and also the respecting liquid. Yeah, so in this case, in the extraction, these points tell you the concentration of C in the extract and also the concentration of C in the respecting raffinate. All right. Okay. Any other questions? Or still confusing? All right. I think about drawing this one, we can use a practice or maybe another tutorial if you still need it. Yeah, step by step, and then maybe we give the quiz, and then you can print it out first, so you can try it using your ruler, and then now I need to discuss the next steps. Yeah. All right. Okay, so this curve, yeah, the curve that I explained to you between the y and x is very useful for multi-stage or the countercurrent extraction. Yeah, again, you understand about distillation. Yeah, in distillation you have remember in one stage there are y, for example, coming and also the x coming from the liquid, yeah, the liquid coming from the stages, and also here there is x0 and also y2, and then the vapor coming from down there to the stages, yeah, and then you got the distillation. Okay, and if you remember, in the distillation you have the graph, and then you also have an equilibrium, and these points in the distillation tells you about the correlation between the x and y, and also you also have what is called the yeah, the again the operating line, yeah, if you remember, operating line that tells you regarding the correlation between the x1 and y2, remember, and this is the operating line, and also this tells you about the equilibrium. Yeah. Okay. In the extraction, it's also quite similar. Yeah, it's actually quite similar. So we have numbered points of extraction. The first one is the co-current extraction, so it has a similar flow, but it is not common, and also of course impossible, because when you have a contact with the feed, it just have similar E, yeah? So it doesn't, it's impossible. The second one is the countercurrent. The countercurrent one, it is very similar with the distillation. So sometimes in the operation, the choice or the selection, sometimes it can be we can use distillation or we can use extraction. So sometimes it is quite competing, sangat bersaing between the distillation and extraction, particularly for essential oils or some low temperature components. Now, what happened is in the extraction, first, please, before we go to the graph, please understand the basic mechanism. Give me 1 minute, I need a glass of water. Okay, in the countercurrent extraction, suppose we have n stages, ada 6 tahap. Suppose we have n stages, and in the beginning, in the stage 1, we put F, we put F, and then in the other sides, the stage N, we put S or the solvent. So we put the solvent. In here we put the feed. Okay, so in one type of stages, it can be mixer and settler, one type of settler. The solvent will contact with the raffinate in the end stage, and then it will mix together, and then because of the mix together, there is a contact between the liquid and liquid in the interface, and then there is a mass transfer of the solute, and it will leave out to the extract and the raffinate. The way we name which one that leaving the stage is also similar to distillation. So if it is stage N, then it's gonna end up with the EN and also the RN, the E, the extract, and also the raffinate. Okay, now and it goes so several times up till, for example, this is in the stage 3, for example. So in the stage 3, we have E from the next stage, which is the E4, because the next stage is 4. So from the E4 is in contact with the raffinate from the previous stages, or the stage 2. And then it will contact together, and then mixing, and then with the mixing there is a intimate contact with the liquid. They're just gonna mix them together, and then after that it will approach equilibrium, and after that it will approach equilibrium. There would be separated in a settler, and after that after settling, maybe because of the difference of the density, one would go to the extract phase and one to go to the raffinate phase. The extract that leaving the stage 3 is called E3, or the extract number 3, extract stage 3, and the raffinate that leaving the stage 3 is called the R3. Okay, this also similar with the stage 2 and also the stage 1. The countercurrent extraction, of course, is possible because that will we can have the solvent will contact with the RN there, RNC, it will good, and then the EN and also RN would be in equilibrium. Okay, so like I said before, for the separation of rare earth metals, neodymium and so on, I read in operation in France, it can be 90 stages of extraction. Yes, it may be similar with if you calculate the tray column, how many unit trays that you need for the separation. So like distillation, in the end you will have enriched extraction, E1, and also your Rn would be very, very depleted in solute. So you have a low C in the Rn. Okay, now the next question is how to describe it. So here, if you use the equilibrium curve, because again, where is it? Okay, so in the equilibrium curve from maybe, yeah, so we can, this is very beneficial with the equilibrium. So for example, here we have one stage, two stage, stage 3, and so on to stage n. That's tell you about the that one, yeah. So for example, this is the feed, yeah, and then it's contact with the E2, and then that will mix together, and then it's gonna leave out with E1 and R2, R1, sorry, yeah. E1 and R1 we can put it in I don't know what is this one, yeah. Maybe it can be, it may be around typical points, yeah, one point there. I don't know this one, what does it mean, yeah, I don't know this one. Okay, so I think we can, so this, yeah, all the correlation, yeah, in the one that leaving is a equilibrium. And then you can write the equilibrium composition between the raffinate and also the extract using the equilibrium curve that you just made before. It is converted from the triangle diagram, yeah, from the tie lines. Okay, so I think we can start how to write it. I'll just try to explain how to put the multi-stage countercurrent from to the triangle diagram, and or also to the XY diagram. Okay, now so here is the schematic, yeah, the schematic of multi-stage of countercurrent extraction. This is, let's say, stage 1, stage 2, and so on up to stage n. Yeah. For the mass flow, we called it F. Yeah. Or for F we can call it a raffinate 0, because it is a stage before 1 is 0. So let's say just equal to raffinate 0. And the mass, of course, the mass flow or the mass rate will have a composition, and the composition is we can call it the composition of C, yeah, or percentage of C. We call it X, yeah. So X usually refers to raffinate, yeah. So the one that leaving the stage 1 is the mass is called R1, and this one is called raffinate. Okay, we use small. I think we should use small x. Yeah. So we use why we have to use small x and also small y, because later on we will also, next week we will learn also the solvent-free basis, like in the absorption. So we will use another notation. Okay, and then it will contact with the Y2, and then it will end up with the X1 and also the Y1. So again, for the extract, the E is the mass, and the Y1 is the composition of C in the extract. Okay, that's why the graph of XY is going to be very beneficial, because they will tell you the composition of the equilibrium between the raffinate and the extract, the leaving one type of stages. Okay, so let's see. This is the problem design, the design problem. For example, we know the concentration of the feed. We know the raffinate, yeah. Sorry, the concentration of the feed. We want to know the extract or the Y of the solvent, and then we know the feed. We want to know the solvent, the mass rate of the solvent, and also the feed. And the one that the outcome or the output that we want is usually the xn. So xn is the remaining percentage of C in the raffinate. Why? Because economically, when we do extraction operation, we need to calculate how much the product that we want should be leaved out. Yeah, because in the raffinate sometimes we put this as a waste, ya, sebagai limbah cair, or it can be recovered. So we have to determine how many percentage C that is still beneficial, is still economic if we don't take it from the raffinate. Yeah, an example, if you want to make tea, for example, you maybe you should maybe you should think how much should I make my tea from the tea bag, maybe one time or two time, for example, because okay, so the other the span tea bag, okay, I think I'm enough with that one. I can put it in the bin, let's say. Okay, in operation, for example, in my case, because I'm dealing a lot with solvent extraction in the mineral processing, let's say I have so just a very quick example. So I have nickel laterite ores. This is tanah, yeah. So we use nickel laterite ores as the raw material for making battery cathode for electric vehicle, and then this one goes into leaching. So leaching is looks like making tea, yeah. You have you have the ores or the soils there, and then you contact it with acid, and then you separate it. So you have the spent ore, and also you have the solution. So the solution contain nickel 2+ solution. Yeah, sometimes this is very dilute, or also there's another impurities like iron and aluminum and chrome. Yeah, while the one that we want is only the nickel. So what I do next is I contact it with another solvent. Sometimes it's organic solution, so I contact them with the extraction. Okay, and in this extraction, or we call it a solvent extraction, we contact the nickel, so then we can get the extract, the nickel in the extract, which is higher than the composition is higher, or lebih pekat, ya, is more concentrated, and then we can leave out the raffinate, which is the raffinate is the acid plus low nickel plus the iron and aluminum and so on, yeah, and chrome, yeah. So in the solvent extraction, the company should think how much the nickel that I should be extracted. Yeah, is it 99% or is it 98%, or maybe 97% is fine. So the remaining, the low nickel 1% or less than 1%, I can maybe regenerate it to make the sulfuric acid, yeah, for the leaching. Okay, but the nickel that I can process up to later on to be like electrolytic process, yeah, or we call it electrowinning to get the nickel metal, yeah, for the next one is only maybe 99% from the initial nickel that I have around this area. So the xn, yeah, the desired xn, the remaining nickel there, usually it can be the problem formulation, how much the nickel that you want to put left in the raffinate, or in this case in the acid solution. Okay, just a very example of my application of the extraction. Okay, so again back to here. So the problem design is to find the feed and the and we know, so we know the this is the composition of feed, we know that, of course. YS is the composition of solvent. This is the mass rate of the feed, we also know, and also how much solvent you put, the ratio between F and S also you know. Okay, and then the desired is the xn. So after that, because you know the remaining nickel, yeah, or the xn, then you will can calculate how much E1, yeah, or the extract that you got. Now the question is usually what is the number of the theoretical stages needed to get the E1, or to get the to get rid of the nickel based from the previous one, yeah. So the theoretical stages, the higher you have the stages, of course you can get more of your solute in the solution, or in my case how much nickel metals that I can get rid of from my acid solution. It's based on how many stages of my solvent extraction. All right, let's next step. Okay, so let's start from the analysis. Okay, so first we're gonna draw. I think I can put it like this, yeah. So first we gonna draw again. There's a similar one. Usually in the class I would pause this and then ask the students to write it by themselves in their book, so they can have an idea again which stream contact with which stream, and then what is the outcome of the stages. Okay, but look, yeah, it looks like we can't do that right now. So if you want to draw, or later on when you read when you watch the videos and then want to try to understand, please, this one is a very important, yeah, draw the concept. Okay, last week, last year we have one very difficult question in the exam, and then it tells you really about how much you understand about the concept. Okay, so don't really look at the graph. Understanding the graph is good, but the more important one is how to understand the concept. Okay, so again the concept is we have the feed, and in this case in here we have the solvent, and the feed is contact with the R2, yeah, and then it's gonna leave out with the Y and X, yeah, or the E1 and also X1. In distillation we have we have equilibrium and operating line. In extraction, what do you think? Do you think we have operating line as well? Looking at the schematic, is it going to be helping us if we have operating line? Anyone? Okay, I think I'll just go back to the concept. Who want to answer? Yeah, Dia. Dia, what is the purpose of equilibrium curve?
Halo, Bu.
Yeah.
Hello.
Yeah. Hello. I can hear you.
Yeah, why can I hear my... Nggak bisa denger Bu. Ibu ngomong, Bu.
Yep. Give me 1 minute. Yeah, my battery is almost it's very low. Just wait. Okay, my battery is really low right now, so I need to charge them first because I moved to my dining room. Okay, or Fatia, are you listening? Hello?
Yes, Ibu, I'm listening.
So Fatia, what is the concept of equilibrium curve? We want to know the correlation between the composition of the C in the extract. Remember the tie line? Yeah, the composition of E and also the R, right? The composition of C in the extract and also the composition of C in the raffinate, right? Is it correct?
Yes, Ibu.
Yeah. So, okay, help me, Fatia. Do we know F?
Yes, Ibu.
Yeah, we know the F, yeah. Okay. Okay. If we don't know the correlation between F and E1, right? So just leave it out. If we have E1 or we have composition of Y1, do we know the correlation between the X1 and R1? Do we have this correlation? The extract leaving the concentration of C live in the extract and also the concentration of C in the raffinate. Do we have the correlation? That's the one that I'm asking, yeah? So the correlation between the Y and the X, it is called? Anyone want to answer?
The equilibrium, Bu.
Yeah. Yeah. The equilibrium. Yeah. So so in the beginning we will have so here we will need equilibrium curve. Yeah, we need equilibrium curve. Okay. Now, in the distillation, if we have, for example, this is Y1 and X1, this tells you about equilibrium. What is the correlation between Y and X in the horizontal one? Do you remember what is the correlation? The one that X that going into the stage and also the Y leaving the stage. What is this correlation? Again,
Operating line.
yeah, operating line. So we can also get the correlation from with in this case in the vertical one, for example around this area or around this area, by finding what we call the with operating line. So it is actually similar with the distillation, where there's equilibrium and operating line. There's equilibrium and operating line. Okay. Now, to get the operating line or to get the correlation between those two, the one here, we're gonna use it the mass balance. So let's say we use the mass balance between throughout the system with this envelope, the red envelope, and here we have the F going inside. Yeah, F going inside with the concentration of F for the composition, plus with S, yeah, because solvent also going inside the envelope, ya, masuk ke dalam kotak ini, with the composition of YS. Yeah, that one there. That's equal to the stream that leaving out those envelope is E1 multiplied with Y1 plus XN multiplied with RN. Okay, or because this is the component, yeah, mass balance, and also this is the mass balance. Okay, so so there are two mass balance. This is the first one for the mass balance, and the second one here is the component balance. What component? The C component, yeah. Okay, so we can draw here with this one, yeah. We can draw it in a triangle diagram there. Okay, so here, for example, this is a triangle diagram. This is the solvent, yeah, for example B, and then also the feed, let's say, or equal to raffinate 0, and then it end up with let's say extract, the higher one, the higher extract, and also the raffinate. Remember, the E is not equilibrium with Rn because E1 is in equilibrium with what? E should be equilibrium with R1, yeah, E1 equilibrium with R1. Okay, but because it is a mass balance, so if we add R0 plus En plus 1 would be equal to E1 plus Rn. So if we have R0 plus En plus 1 equal to R0 with equal to E1 plus Rn. Now the next step, okay, so and this one is not a tie line. Now the problem next is how to get the operating line, yeah. So I'm gonna add one more I think extraction 4, and just give a minute to find the files. Hand out the part and 5, I think. Okay, yeah, so I'm just gonna read, I'm gonna write again this one. So you have stage 1, you have the feed, or the feed can be write as RO, yeah, and then here you have E1, okay, and then we have maybe R1 goes to the second one, and then this is E2 and so on, and then this is N, you have n or n plus 1, yeah, or equal to s, and this one is your Rn. Okay, so this Rn is this one, yeah. Your En plus 1 or s is these points, okay. E1 is these points, and then f is that points, okay. Now if we try to look at the envelope there, then we can have the correlation that E1 plus Rn equal to S plus F. Now, if we now to understand what is the operating line, we can maybe for example, in this case, I think I'll just put this one there, yeah. Sometimes there can be like this, sometimes it can be like that, yeah. Let's say this is the graph that I explained. If you connect the line between E1 and F into one point there, delta, we can call it this point as delta R. And here we also connect the point from the S and to Rn into a delta R, okay. What does the delta R explain? Okay, so delta R, if plus with E1, yeah, okay, if we have these points, yeah, delta R, okay, 1 point, if we plus the E1, that become R0 or F, okay. This also tells you that if n equal to 1, if we have delta R, for example, yeah, delta, and we have, let's say, delta R plus En plus 1. So I think I can explain it like this. So if in this point, if there is two lines, yeah, if I have A and B, if we add them together, the mixture would be around this one, for example, M, yeah, like that, okay. This one as well is the same. Delta R, for example, if this is delta R plus E1, if we add it, it becomes in the middle, which is F. Or in this case, with this line, delta R plus S, when we add it, it becomes Rn. Okay, so it is written again in here. So delta R plus E1, that become R0. Delta R plus En plus 1, it become Rn. So if we change this n with 0, so delta R plus n equal to 0, yeah? E1 equal to R0. If we change n equal to 1, delta R plus E2, it become R1. Delta R plus E3, let's say, it become R2. Okay. Now go back to the correlation. So in the correlation, maybe I'll just draw a smaller one here. This is stage 1, stage 2, stage 3. So this is E1, this is E2, this is E3, this is R1, this is R2, and this is R0. If you just have a correlation here, so the correlation between E2 and R2 is in here, right? The correlation is E2 and R1 is in here. the correlation between E1 and E0 is in here. So these correlations tell you something about operating line. They tell you about operating line. So that means if I want to have any correlation about the operating line, because operating lines tell you the correlation between R2 and E1, then I just need to put it into the delta R. Okay, so in this case, delta R is the one point that tells you about operating line. Any line that pass the delta R will tell you correlation of the operating line between the R and the respecting the E coming from the next stages. Okay, so it tells you the relationship between Rn and also the E1. All right, looks like it's almost 11 o'clock. So so this tells you, so for in summary, I'm just gonna write the summary here. So for the operating line, so this is operating line, yeah. To know which one is the operating line, then you have to use a delta R, yeah, and then this tells you the correlation between, for example, R0 and E1, for example, R3 and E2, or for example, R2 and R3 and E2, for example, yeah, R3 and E2, or and so on. Itu yang terbalik ya ini ya. Okay, so it tells you this correlation. Yeah, so this is using the delta R. Okay, now if we know the operating line, how about the correlation between the this one, E1 and R1? What is the correlation? Of course, equilibriums, yeah. So here, so again, what you need to do, you have to find equilibrium correlation. It can be tie line, it can be XY curve, or tie line. And the second one, you want to find the operating line. Yeah. So first you have the feed. If you know the operating line, you can find also the E1, yeah, and then from the E1, then you check your tie line to get the R1. Once you got the R1, you check again the operating line to get the E2, and then when you get the E2, and then you check again the tie line to find your respecting equilibrium, and then so on until you get your Rn. Okay, so in summary, just a little bit finishing up, but we can explain it again next week. It would be looks like yeah, it would be looks like this one, yeah. So for example, but this is still using the triangle diagram, yeah. So here, for example, between water, ethyl acetate, and the acetone. So the acetone is the percentage of C in this case, yeah, the vertical one, that the one that you want to get, and then they collect them. Yeah, so the acetone is in water, it is extracted with ethyl acetate, yeah. So here, first we have the feed, yeah, we have the feed, and then it's contacted with the solvent. Where is the feed? Maybe somewhere, I don't know, yeah, the feed. And then this is the extract envelope, this is the raffinate envelope, and this is the plate point. And then we have to calculate the tie line and also calculate the operating line. So this P, or the delta R, it tells you about the operating line. Okay, so I think we can continue this next week. And then I think we only have one week left, yeah. Yeah, isn't it? Yeah, we only have 1 week left. So next week I'm gonna tell you step by step to calculate this one, the R square and so on. Yeah. All right. Okay. Thank you very much for your attention. So the question up to here is until you find the operating line. The next Thursday, hopefully, I can explain to you about the how to create how many stages, yeah, between the operating line and also the equilibrium correlation. All right, thank you very much, and I'll see you again next week. And also, before we stop, so have you, Fatia, have you written which groups? So we agreed to have a tri-column presentation next Friday, right?
Yes, Ibu. We decided the timings as well.
All right, okay. All right, thank you very much, and then have a good day, have a good weekend, and then I'll see you again next week.
Excuse me, ma'am.
Yeah.
On the schedule on 6th, it says that there are no. I mean, yeah, we have the presentation next week, but there is no kuliah next week. Is that a mistake or is that true?
There should be kuliah because next week is the last week.
On Friday, so that's just a mistake, right?
Yeah. So let me check my schedule. Yeah, we still. Oh, yeah, you're right. Why there's no?
Also, I want to ask regarding the third exam. Is it during the UAS week, Bu?
Yeah, the third exam during the UAS.
Okay, thank you, Bu.
Do we have a holiday on 3rd of December?
I don't think so, ma'am.
Ibu, I think it's like minggu tenang gitu deh, Bu. Before the...
We still have quite a bit of exercise, actually. So it's really up to you. Do you want to have a courses or not? If not, then but I would recommend still do the kuliah, yeah. Okay, is it okay?
I think it's okay, Bu.
Yeah, that would be fine, ma'am.
Yeah, okay. So because we're still in extraction part 4, and yeah, I don't know why, but I try to make it similar with regular classes, but looks like we're a bit late of the schedule. So anyway, but if you still think that it's still not enough for your exam module, I would be happy to get another maybe class, yeah, with you, or a type of tutorials with you outside the class to prepare the exam. All right, everyone, thank you for telling me, and then again, thank you, and I'll see you again next week.
Excuse me, Bu.
Yeah, okay, Nadifa.
Ibu, do you mind uploading the recording?
Yeah, I will upload now, so you can have bakal, yeah, for the weekend. Thank you. Bye bye.